So in this lesson, 5.2, we're going to talk about medians of triangles. And basically, if you haven't done your warm-up, go ahead and do that. I will post the answers here so you can check with. So try those, and then we will talk about identifying and using medians. So remember, a triangle, all the angles in the three add up to 180. That's what you're using for these 1 through 5 measures. And then you're adding the two remote and equaling it to the exterior for number 2. So medians. A median is a segment that connects the midpoints of a side with the vertex of the opposite angle. And where they meet is what's called a centroid. Okay, and it splits that into basically thirds. This ends up being a third, this ends up being 2/3. So I always kind of do the rule of you're either going to double it, half it, or divide it by 3. So if you know, let's write in what we do know, CM here, and it's the smaller part. So we know that we're going to double to get this longer segment on HM. So HM would be 16 plus 8, since CH is 16, then we get 24 for the whole segment. We know that YV is the whole. So whenever they give you the whole, you're going to divide it by 3, and then that's going to give you this smaller segment 4. And then we know that we double it, and that would be 8. And what is 4 plus 8? 12. So YP is going to be 8, and PV, the shorter, is going to be 4. So take a look at this one. We know that CG is 6. That's the longer of the two parts. And then GF here is the shorter of the two parts of AF, and then FB is this outer one there. So see if you can answer those 3, push pause, and then push play to check when you're ready. So GE here is going to be half of the longer segment. 4, this one is 2, so this one is going to double to get AG. And then if this is 7, well, then this one is 7, because this is the midpoint. So let's take a look at it in a coordinate plane. So here's my triangle. These are the midpoints. Just went ahead and gave you them. And there's I, kind of got shifted away. And what we do is we just connect those to the opposite vertex. And so we're looking for this centroid point, okay, where they intersect. Well, that's kind of hard to tell where that is because it's not on a cross section, and a lot of times it isn't. So the easiest way is to use this formula where we basically add up all the x's and divide by 3, kind of average them, and then add up all the y's and divide by 3. So we're not going to use our midpoints. We're going to use the original vertex points D, E, and F. So all my x's are right here. And I'm going to add 2, 8, and 6. 2, 8, and 6, and divide by 3. And then I'm going to add all my y's up, and I'll reduce that in a second. 3, 5, and 1. Add them. 3, 5, and 1, and divide by 3. So let's go ahead and add and simplify. This is my x coordinate. This is my y coordinate. So 2 and 8, that's 10, plus 6 is 16. And then 3 and 5, that's 8, that's 9. All right, so I can go ahead and do 9 divided by 3, that's 3. And then this one, you can leave it like that, or you can actually divide by 3 in your calculator and get 5 1/3, or 5.3 repeating. So that's why we're kind of, we're at 1, 2, 3, 4, 5 1/3, and up 3. 1, 2, 3 at that point there. So go ahead and try it on this one. Here's your 3 points. Add your x's, divide by 3, add your y's, divide by 3. And you're going to wind up with 4 1/3, 3. So at 4 1/3, up 1, 2, up 1, 2, 3. So if we did midpoint, 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 actually it would be, didn't go up all the way. No, that's 4. That's why. 12 divided by 3 is 4. There we go. Gotta do my math right.